In this video, we will configure dynamic routing using the RIP routing protocol. So in the very first video, we showed you that configure all the basic configuration. That means configuring all your interfaces with the correct IP addresses, making sure they're operational, and doing basic connectivity between the devices. Always do that first before enabling advanced features like routing or NAT or maybe firewall policies, because then that can avoid doing troubleshooting on the basic stuff. Before we configure RIP routing, we have static routes that we did from a previous video. Let's go ahead and remove all those routes at this time. So on R2, let's go ahead and do a show run to see what those routes look like. It's towards the bottom, and here it is, one route. Let's go ahead and copy that. And let's go into our config mode and let's remove that static route. So now let's go ahead and enable RIP routing on R2. So we need to define the routing process. So to do that, we'll do router, then the routing protocol, which would be RIP. And let's do enter. Next, we'll define version 2, because there's two versions of RIP, version 1 and version 2, but version 2 is recommended. Now we're going to define the networks that are connected off of the interfaces that are configured. So R2 has two interfaces. So here, the network here would be 192.168.2.0. And the network here would be 10.1.2.0. So those networks we need to define under that routing process for what will be advertised to the other routers. So let's first do the LAN subnet, 192.168.2.0. And let's do network 10.1.2.0. Now something's going to happen. So we did this on purpose. Now once we configure that, let's go ahead and exit out and look at our running config. Let's look under the RIP routing process. So we see the routing process of RIP defined. We have our version 2 and we have our LAN subnet listed here. But our WAN subnet that we defined as 10.1.2.0, it changed it to 10.0.0.0. Why is that? The reason is RIP is a classful routing protocol. That means it does not look at the subnet mask information and how it's configured. It uses the classful boundaries of a class A, a class B, and a class C. So for this network here of 192.168.2.0, the first octet falls in between the range of being a class C network. Therefore, the first three octets are the network. The rest is ignored. So that's why that's represented correctly. But the other one, even though we configured it with a longer subnet, the first octet, which is a 10, falls into a class A network range. That means the first octet is the network and everything else is for host. So us typing in 10.1.2.0, it didn't care about that. It only cared that it saw it as a class A network, so it would be represented as 10.0.0.0. Now if we configured a classless routing protocol like EIGRP or OSPF, for example, it would look at the subnet mask information that we configured with that route. So moving forward, we're going to only configure the classful boundaries for the networks for the other interfaces in our environment. Now let's go to R1. Let's do a show run so we can see our static routes that we need to remove to clean things up. We're going to filter only our static routes. So these two static routes we need to remove. Let's copy the first one and remove that. Say no again and remove the second static route. Now let's configure RIP routing. So first we do router RIP. We'll define version 2. Then we will list our classful networks from our connected interfaces. So our LAN is pretty simple, a class C. Now for the WAN interface, we have two interfaces on R1. Now that's a class A network. So that basically means 10.0.0.0. That's all it's looking at. Let's go ahead and exit out of the config mode. And then let's proceed to R3. Let's go ahead and remove those static routes that we configured. Now this, we configured a default route from a previous video. So let's go ahead and let's say no, and then let's copy this and let's remove that. Now let's configure RIP. Router RIP version 2. Then let's define our classful networks from our connected interfaces. And our WAN interface, which would be 10.0.0.0. And let's exit out the config mode. So that is it. We configured RIP on router 1, 2, and 3. Now let's confirm that our RIP routing environment is working. Now since we're on R3, the most important command to use to confirm that routes is working is looking at the global routing table. So that command, let's go here, would be show IP route. And here we do see RIP routes in our table. We see that router 3 has learned routes of 192.168.2.0 via RIP, which belongs to the segment, the LAN segment off of R2, including the LAN segment off of R1, which is 192.168.1.0. So we see that information there, including the WAN interfaces as well. So we see the 10.1.3, which is connected, or we see the 10.1.2 network that is being advertised via RIP. Now for these routes here, we see additional information. So for the 192.168.2.0 network, so it's a class C, so it's a /24, the classful boundary, is learned via RIP, and we know it's RIP because the code of R is reflected up here as R is to RIP. Now next to it we see 120. This represents the administrative distance, which is the default for all RIP routing. Next we see the metric, or the number of hops it is to reach that network. So it is 2 hops away to reach that network, or 2 routers. So that basically means 1, 2 to reach that network. And we have learned this network via the router of 10.1.3.1. This is the next hop router, which is router 1, obviously. And we received information on this update, or for this route, 2 seconds ago. And that this interface that is routed through is serial 0/0. So if you're configuring routing or troubleshooting routing, show IP route is a great command to use. So get comfortable with what's presented here. Another command we can type in is show IP protocols. But we'll talk about this command a little bit further in a separate video. So having routes in our routing table is one thing, but we need to confirm connectivity to some of these networks. So from R1, let's do a ping test to the LAN segment of R2. So we're going to ping 192.168.2.1, source from our LAN interface. And we're reachable. So we can reach from point A, which is our LAN segment, to point B, which is the LAN segment for R2. So very quickly, let's do the same thing on R1 and R2. So let's go to R1, and first let's look at our routing table. And here we are receiving RIP routes, one for the 3 network and one for the 2 network, the 2 LAN segments for these routers here. So let's do a connectivity test, and let's ping the LAN segment of R3. So that'll be 3.1. We're going to source from our LAN interface. And we have connectivity. We could also type in show IP protocols that will confirm that RIP routing is enabled, which is reflected here, and the networks that is being advertised. And last, let's go to R2, and let's look at that routing table, which will be very similar to R3. And we are receiving RIP routes. We see the R3 LAN segment of the 3 network here, and the 1 network for the LAN segment for R1. And we see the segment of 10.1.3 being advertised via RIP, which is for that segment here. And we are finished. So that is how we configure RIP routing in the environment, how we can check the routing table by doing the command show IP route and show IP protocols, which we'll talk about in the next video, and how you can confirm connectivity. Because even though there are RIP routes or routes in our routing table, you want to confirm connectivity to those devices. So we have confirmed that RIP routing is working correctly in our environment. With RIP routing working in our environment, let's run through a couple commands for monitoring the operations of RIP. Now, one of the main commands is show IP route to look at the global routing table. But another command is show IP protocols, which is also very effective. For example, all routing protocols configured on a router, we can view that. Like we know that RIP is enabled on R2. If there's any filters configured, we can see that as well. And this pertains to what routes we receive or routes we actually send out. We also see details of the timers. And we know that every 30 seconds, which is listed here, updates is sent of the entire routing table to all routers. And that the next sending of updates will happen in 12 seconds. We also see the invalid timers, the hold down time, which is 180 seconds, and the flush timer, which is 240 seconds. This is something we'll discuss further in IC&D Part 2. You also see details of the version that we're sending and receiving, that we specified version 2, which is recommended. We can also see if summarization is enabled. We can also see what networks are being advertised, configured under the RIP routing process. And we see the routing information sources, which is something like a neighbor. So it knows that R2 is connected to R1. So one of the gateways is 10.1.2.1, the IP that's configured here. So it's receiving routes from R1, which is the gateway. We also see the administrative distance for RIP, which is 120, the default. So the show IP protocols is a great command to use. Another command is a debug command where we can see what routes we are receiving and what routes we are sending. That would be the command debug IP RIP. Now remember, every 30 seconds we send out our entire routing table. So here we see that we send out our routing table out of the interface of FAS Ethernet 0/0 via multicast, since we're using version 2. You see basically these are the routes we know about, and that's what's being sent. These are routes in our routing table that we're sending out of FAS Ethernet 0. But we also see the same thing of sending routes out of serial 0/0 and routes we are receiving, like from 10.1.2.1, the IP for R1. And you see that we receive routes for the 10.1.3 network, which is for the segment here, for the 192.168.1 network, and the 3 network, which is the last segments here. So this is a great command to use to confirm if we are sending out updates and if we are receiving updates and what those updates are.